Now the questions of the type integration 1 over 1 plus x4 dx. Have I done this type of questions? Root tan x. Okay. Root cot x. Integration of root tan x plus root cot x. So now the questions involving integration of root tan x, root cot x, 1 over 1 plus x to the power 4, or x squared divided by 1 plus x to the power 4 dx. All these are typical questions which have to be done by a specific method, right? So let's see how to answer these kind of questions. Suppose you want to answer this question. So let's start with I. Dx divided by 1 plus x to the power 4. तुम्हारे दिमाग में ये भी आ रहा होगा कि x टू द पावर 4 को एक्स स्क्वायर का होल स्क्वायर लगा दो फिर tan इनवर्स कर दो, ठीक है? आ रहा है ना किसी के दिमाग में ये बात कि यू कैन राइट dx डिवाइड बाय 1 plus x square whole square and it is tan inverse x square. But this is not correct. If you differentiate tan inverse x square, its derivative would be 1 over 1 plus x square to the power 2 into derivative of x square, which is 2x. Its derivative would be this. So this is not correct. So let's start with this question. We start I is equal to dx over 1 plus x to the power 4. First step is dividing numerator, divide numerator and denominator by x square. This question has to be done by a specific method. Those steps you have to remember. So dividing numerator and denominator by x square. Oof. So we divide numerator and denominator by x square. So this is 1 by x square plus x square dx. Write this much. So this is the first step. So dividing numerator and denominator by x square. The next step would be multiply numerator and denominator by 2. Multiply numerator and denominator by 2. That is the next step. So 1 by 2 out. This is 2 by x square over 1 by x square plus x square dx. So that is the next step. So first we divide the numerator and denominator by x square. Next we divide by 2 and multiply by 2. So I think everyone today is taking online class. Hmm. So after this, you split 2 by x square into 1 by x square and 1 by x square. At the same time, add 1 and subtract 1. That is the next step. So next step is we are adding 1 and we are subtracting 1, and it is we have split 1 by x square into 2 and denominator as it is. And the next step would be that we basically separate into two integrals. I is equal to 1 by 2, 1 plus 1 by x square divided by 1 by x square plus x square dx. And I take minus sign common. 1 minus 1 by 2, 1 minus 1 by x square over 1 by x square plus x square dx. And let me call it 1 by 2 I1 minus 1 by 2 I2, equation number 1. Just go through it again once. एक बार पूरा go through करो मैंने क्या किया है. Right from the beginning, go through. Done? All right, Janvi, Meera, Anuj,
Yes,
Zaina,
sir.
Yes, sir.
Anya,
ये नहीं है, ये रही।
जानवी अपना ऑफ करो. Anya, Akshara, on karo camera.
Yes, sir.
Done till here. So after this, what we do is we'll take I1, integrate it, then we'll take I2 and integrate it, right? Minus common ले लिया. So now I'll integrate only I1 first. In I1, you have 1 plus 1 by x square divided by x square plus 1 by x square. Tell me, numerator is derivative of what? Which function's derivative is the numerator? 1 plus 1 by x square किसका derivative है? 1 plus 1 by x square is derivative of what? 1 is derivative of x, plus 1 by x square is derivative of minus 1 by x. If there's a confusion, integrate this only. So let this is equal to y. Let x minus 1 by x is equal to y, because its derivative is present in the numerator. Now, if I differentiate both the sides, it'll be 1 plus 1 by x square dx is equal to dy. And if I square this, it'll be x square plus 1 by x square minus 2 is equal to y square. That is x square plus 1 by x square is equal to y square plus 2. So just look at this. Is it okay? इट्स ऑल राइट अक्षरा, शनाया? शनाया बरोबर है?
Yes, sir.
ऑल राइट। चिराग, लॉन्ग टाइम नो सी।
एग्जाम में एग्जाम चल रहे थे।
अच्छा अच्छा, ऑल राइट। सो denominator is y square plus 2 and the numerator is dy. Now it has reduced into a standard integral after this substitution. This is standard integral. Which standard integral is this, Rin? Y square plus root 2 is root 2 whole square. Which standard formula is this? 1 by a tan inverse y by root 2 plus c1 or 1 by root 2 tan inverse. What is y? Y is x minus 1 by x. So call it equation number 2. We'll be substituting I1 later in equation number 1. So I've done I1.
So same method for I2?
Yes, similar. And I2 will be done by similar method. For I2, just ask yourself whose function's derivative is 1 minus 1 by x square. Hmm. So in I2 we have numerator 1 minus 1 by x square. So it is derivative of x plus 1 by x. Let it be equal to t. So it's derivative 1 minus 1 by x square dx is equal to dt. Squaring both the sides give you x square plus 1 by x square plus 2 is equal to t square. That is, I2 will reduce to dt divided by t square minus root 2 the whole square. So this is I2. ये किस kind, which standard formula is this?
1 upon 2a log x minus a
Yes.
x plus a.
Yes. So this is 1 by 2 a log x minus a or x plus a. So it's done. So 1 by 2a is root 2 log a minus x plus over a plus x. And then you can replace. This is equation number 3. So I have I2, I have I1 and I2 substitute equation number 1 and you get your answer. So this question is worth 5 marks for boards. Otherwise, entrance also it could be there. And you have a typical method for this. This is how you can answer this question. There's no other method. And all those questions, root tan x, root cot x, they're all the same. Asmi, Asmi, have
Yes,
you
sir.
join कर लिया तुमने? You are there?
Yes, sir.
Good. Finally. First online class. चलो,
हाँ सर, वो पास यहाँ पे ही।
मिस करने से बेटर है यू अटेंडिंग क्लास।
यस सर।
गरिमा तो है भी नहीं, ऑनलाइन में नहीं है, मतलब शी इज इन ऑफलाइन। तुम्हारे लिए स्टफ गार्लिक टोस्ट लाई थी वो आज, चीज, तुम आई नहीं। ऑलराइट, लेट्स आंसर रूट। एनी डाउट इसमें? शैल आई मूव नेक्स्ट पेज? लेट्स आंसर रूट tan x. For root tan x, root cot x, you can take tan x is equal to t square. because we want to get rid of under root. Differentiate this, it will be sec square x dx is equal to 2t dt. So dx will be 2t dt divided by 1 over tan square x, 1 plus tan square x. So dx will be 2t dt over 1 plus t to the power 4. Notice this is not t square. It is t to the power 4, which is sec square x. Sec square x is 1 plus tan square x. Tan x is t square, so tan square x will be t4. So by mistake इसको t square मत लिख देना. Sec square x is 1 plus tan square x. So you make two substitutions. Tan x is t square and this is this. So after this, what happens? It'll be t into 2t dt over 1 plus t4. Or this is I is equal to 2t square dt over 1 plus t4. And now this is the same question as we have just done. See, previous question में क्या था? It was 1 over 1 plus x4. Now we have 2t square by 1 plus t4. More or less same only. Same process. Divide numerator and denominator by t square. So this would be 2 dt by 1 by t square plus t square. And then you split 2 as 1 plus 1, 1 plus 1. Split कर लिया हमने. And then add 1 by t square and subtract 1 by t square. Adding 1 by t square, subtracting 1 by t square. Split into two parts. Now the same question, same process after that. I1 and I2 and then solve. This you have already done. So this you take I1, this you take I2 and then make substitution y and z and solve. So this you can try later. You know the process now, right? So this we have already done in the previous one. We'll answer another question. Root tan x plus root cot x, which is equally important for boards also and for entrance also. This question will answer in two ways. One, by converting to sin and cos. Another by substituting tan x as t square. Try yourself. Tan x इसको sin cos में convert करो and do it. Convert tan and cot into sin cos, take LCM, substitute and answer. Convert into sin and cos, take LCM. Convert into sin and cos, take LCM. Sin x by cos x by sin x. After taking LCM, it will be sin x plus cos x divided by sin x cos x. Again, ask yourself whose derivative is this term? It is derivative of, yes. So let this is equal to t. So if I differentiate this, I'll get sin x plus cos x dx is equal to dt. Square this, squaring both the sides, will get you sin square x cos square x minus 2 sin x cos x is equal to t square. This is 1. So 1 minus t square is 2 sin x cos x. So 1 minus t square by 2 is sin x cos x. So now you make these two substitutions. Sin x cos x is this, and sin x plus cos x dx is dt. So the numerator is dt divided by under root 1 minus t square by root 2. Or it is root 2, and this is a standard integral 1 minus t square. That is root 2 sine inverse t. And t is sin x plus sin x minus cos x. We'll answer it by second method. In second method, we'll substitute tan x as t square. Try yourself, second method. Answer by substituting tan x as t square. So tan x is t square, sec square dx is equal to 2t dt. That is dx is 2t dt over 1 plus tan square, which is t4. So this integral would be t plus cot x would be 1 by t, and dt is 2 dt over 1 plus t4. So if you multiply inside, it'll be 1 plus 1. If I take LCM, so it will be, if you multiply straight away, it will be 1 plus t square, no? 1 plus t4. So how to answer this now? Divide numerator and denominator by t square. So 1 by t square plus 1 over 1 by t square plus t square. And this you have already done. 1 by t square plus 1 in the numerator is derivative of t minus 1 by t. Let it be y. Differentiate it 1 over 1 plus t square. Dt is dy. Squaring both the side gives you t square plus 1 by t square minus 2 is equal to y square. So t square plus 1 by t square is y square plus 2. So this is 2 times numerator is dy, denominator is y square plus root 2 the whole square. Which is standard result 1 by a root 2 tan inverse y by root 2. Then you press y, then you replace t and your answer, because depending upon the option, you'll decide which formula to be used. This one or this one. Root 2 tan inverse y is t square minus 1 by t. And then t square is tan x. So root 2 tan inverse tan x minus 1 divided by root 2 tan x. So root 2 tan inverse tan x minus 1 by root 2 tan x. So this kind of questions are there in the assignment, Khana. Question number 16. In the assignment, question number 16, page 11. So you can practice remaining questions. There are only 14 questions, out of which we have already done 3. So question 16, you can answer these, right? Have I done question number 8 with you? Dividing numerator by cos square x. No? Okay. So now the questions which have sin square x, cos square x, or sin x cos x in the denominator. This type of questions where you have a sin square x plus b cos square x, or you have a sin square x plus b cos square x plus c into sin x cos x. So questions of the type where you have no sin cos in the numerator, but sin square x, cos square x, and sin x cos x. A, B, C are the real numbers. It's not a square, it is a. These are the real numbers. Like one of them can be 0 also. So how do you answer these questions? Suppose we have a question, integrate dx by 2 sin square x plus 3 cos square x plus 5 sin x cos x. Suppose this is a question. The rule is simple. Divide numerator and denominator by cos square x. Divide the numerator and denominator by cos square x. करो. dividing numerator and denoted by cos square x. Then you substitute tan x is equal to t. ये कौन सा कर रही हो तुमने ए वाला किया. आई एम राइटिंग 2 sin square x 3 cos square plus 5 sin x cos x. This is the question. So this would be sec square x, which is derivative of tan x. So this is 2 tan square x. It is 3, and this is 5 tan x. Now let tan x is equal to t. Derivative of tan x is sec square x dx is equal to dt. So this becomes dt. You might have c also here. You might have d also here. That'll become sec square x, and you can write 1 plus tan square x. So this is 2t plus 5t plus 3. So now you know how to answer this question. Take 2 common. So t square plus 5 by 2t plus 3. Convert into perfect square and solve. Convert into hmm. So t square dividing this by 2. So 5 by 4 whole square, add and subtract. Then it'll be a standard result. So t plus 5 by 4 whole square. And what about this? It is 1, it is 25 by 3 by 2 minus 25 by 16. Will be negative or positive? T plus 5 by 4, and it is 48 minus 50. Negative. Hmm. Minus 1 by 4 whole square. So which formula? Yes, 1 by 2a. A is 1 by 4 log x minus a. X, we have t plus pi by 4 divided by x plus a. And then you can replace t also, and that's it. Done. So in the assignment, question number 8 on page 8 is basically the questions based on this. And you do one thing, you answer question number 3 of for you. Question 8, page 8. And now you have to answer question 3 of this. कर लो. Sin x by sin 3x. See, if a question involve trigonometric function, all the angles must be same. You can't have sin x and sin 3x at the same time. Sin 3x को convert करो sin x में. Sin 3x की आइडेंटिटी नहीं पता. Great. Sine 3x is 3 sine x minus 4 sine cube x. So replace sine 3x by 3 sine x minus 4 sine cube x. Sin x, you can take common from numerator and denominator cancels. 3 sin x minus 4 sine cube x. So after taking sin x common from denominator, cancel with the numerator. So you have 3 minus 4 sine square x. So now this is that type of question. So dividing numerator and denominator by cos square x. Dividing numerator and denominator by cos square x. Prisha, are you there?
Yes, sir.
Okay. I can't see you. So now this is sec square x dx divided by 3 sec square x minus 4 tan square x. So same substitution, tan x is equal to t, sec square dx is equal to dt. कर लो substitution. शनाया तुम्हारी दोस्त कहाँ है आज?
कौन? किरण?
हम्म
नहीं पता,
ऑनलाइन तो कर सकती है.
मुझे नहीं पता, उससे बात नहीं हुई.
In the denominator you have sec square x, you can write it as 1 plus tan square x. So numerator is now dt. Sec square x becomes 1 plus tan square x, so 1 plus t square minus 4t square. So it is 3 minus t square. Root 3 square minus t square. So 1 by 2a log a plus t over a minus t. And then you can replace tan t by tan x. So this is another similar question, like when you divide by sine square cos square. You might have a similar question, cos x by cos 3x. So there you can use identity of cos 3x. What is identity of cos 3x, Meera?
4 cos cube x minus 3 cos x.
Right, good. So just reverse of that, you know. Have I done those questions like 1 over 1 plus tan x, 1 over 1 plus cot x in the last class? किया था मैंने. When you write numerator equal to a into differential of, कर लिया? Okay. So now we'll move to partial fraction. So if you have polynomials in the numerator, polynomial in the denominator, which is factorizable also, we use partial fraction. What is partial fraction? Type 1. Suppose you have a polynomial, linear polynomial in the numerator and some linear factors like this in the denominator. It could be another factor also. So you can apply partial fraction as long as index of numerator is less than that of denominator. Matlab, numerator में x की power should be less than that of denominator. If they're equal, you have to divide. If it's more, again you have to divide, long division. The numerator index has to be less than that of denominator. Index of numerator is 1 and index of x in the denominator is 2. So we can apply partial fraction. So 2x plus 3 divided by x minus 2, x plus 3 is equal to a divided by x minus 2 plus b divided by x plus 3. If you have a third factor, let's take another factor, x minus 5. So it will be c divided by x minus 5 also. And then you take LCM on the right side. This is basically identity. If I take LCM on the right side, it will be x minus 2, x plus 3, x minus 5. A into x plus 3, x minus 5. B into x minus 2, x minus 5. And C into x minus 2, x plus 3. So you take LCM and cancel LCM on both the sides. थ्री फैक्टर्स हैं, ABC आएगा, चार होंगे तो DA भी आएगा. हाँ, नींद आ रही है ना, कोई बात नहीं. जंग So now you can identify, you can find A, B, C. There are two ways. One method is by substituting zeros of linear factors. Now we have three factors, x minus 2, x plus 3, and x minus 5. I can substitute x is equal to 2 in this identity. So it will be 2 into 2, 4 plus 3, 7 on the left side. When I substitute 2, it will be x is 2, 2 minus 5. So what is A? 5 into minus 3, minus 15. 7 by 15 is A. And these will be 0. The other two factors will become 0. Similarly, you can find B and C also. Karo. Find B and C also. Next 0 would be minus 3. Substitute x equal to minus 3. Put x is equal to minus 3. Find. If I substitute minus 3, will be minus 6 plus 3, minus 3. This will be 0. This would be minus 5, minus 8, and will be 0. So B is coming out to be 3 divided by 40. Then next 0 is 5. Substitute x equal to 5. So x equal to 5 on the left side will be 13. This is 0. This is 0. This would be 5 minus 2, 3. 5 plus 3, 8. So C is coming out to be 13 by 24. So you got all three.
तो b -3/40 नहीं होगा?
Hmm. -3/40. So now we have ABC. But this ABC you replace over here. This, and this. The entire integration. This is the integration. So this is equivalent to this. So your integral now reduces to A is -7/15 divided by x minus 2 dx. B is -3/40 by x plus 3 dx. And C is 13/24 divided by x minus 5 dx. So this integral is now -7/15 log of mod of x minus 2 -3/40 log of mod of x plus 3 plus 13/24 log of mod of x minus 5, and write C also. So this is when you have all linear factors in the denominator. Now, what if one of the linear factors is cubed or squared? It's not a linear factor, but it's having some index also. So this is 4x plus 3. It is x plus 3 whole square. So now we have 4x plus 3 divided by x plus 2, x plus 3 the whole square. Again, index of numerator is 1, denominator is 3. So we can use partial fraction, type 2. So 4x plus 3 divided by x plus 2, x plus 3 whole square. So a divided by x plus 2. And for this, we'll write b divided by x plus 3 plus c divided by x plus c the whole square. If it's cube, then there'll be another term, d divided by x plus c whole cube. So we have to use partial fraction like this. Take LCM, simplify, tell me ABC. करो अपने आप से. Take LCM, find ABC. Hmm. Hmm, hmm, hmm. This divided by this. असमी एलसीएम क्या आ रहा है इसका?
नहीं किया अभी.
बता दो, मुझे तो बता दो. x plus 2, x plus 3, x plus 3 whole square. What is the LCM? Anya,
Yes, sir.
what is the LCM?
X plus 2 into x plus 3 whole square.
X plus 2 into x plus 3 whole square. So, what will be a into
X plus 3 whole cube. So whole
whole
square.
whole square
b into
x plus 2 plus x plus into x plus 3 and then
and
c into x plus 2.
right. Perfect. Now you put zeros. Zeros are x 2 and minus 2 and minus 3. But there are three unknowns, right? So for the third one, what we do is we substitute 0. So take x equal to minus 3, take x equal to minus 2, and then take x equal to 0. You'll find ABC. So when I substitute x equal to minus 3 here, this is 0. On the left side, it will be minus 12 plus 3. This is 0, this is 0, and this is minus c. C is coming out to be 9. Then x equal to minus 2 will be minus 5. A, this is 0, this is 0. A is minus 5. And when x is 0, it will be 3 is equal to a into 3 square, b into 6 and 2c. Substitute values of a and c. You get bk value. So what is b? 5. And then you can integrate this. So this entire integral is equal to this a by this, b by this, c by this. So what is a? A is minus 5 divided by x plus 2. Then what is b? B is 5 divided by x plus 3. And c is 9 divided by x plus 3 whole square. So it is minus 5 log x plus 2, 5 log of x plus 3. And how to integrate the third one?
So x to power n.
X plus 3 to the power minus 2 dx. If you want, you can simplify this further. Take 5 common. Log a minus log b. Right? Then you come across those questions in which one linear factor is there, another quadratic, which is not factorizable. Type 3. You have one linear factor in the denominator and another quadratic factor which is not factorizable, like x square plus 5x plus 7, it's not factorizable. One linear, another quadratic, which is not factorizable. So for these kind of questions, this is the method. A divided by linear factor plus B into differential of the quadratic plus C. Divided by the quadratic factor. So this is what we apply. Sometimes you also write bx plus c, but this again you have to further solve that. So it's better to write this way. Don't write bx plus c, you write b into differential of the quadratic plus c. Let's answer one question. Very important question. Tan x plus tan cube x over 1 plus tan cube x. VIP. Let's integrate this. Tan x plus tan cube x over 1 plus tan cube x. क्या करना है इसमें? करो. First, convert into algebraic problem by substitution. Tan x को t डाल दो, उसका डेरिवेटिव न्यूमरेटर में बैठा हुआ है. Substitute tan x, take tan x common in the numerator first. So 1 plus tan square x would be sec square x. ये आएगा क्वेश्चन एग्जाम में. ये लिखा भी नहीं अभी. Take tan x common. So it will be 1 plus tan square x, which is sec square x. So now we can substitute tan x is equal to t. Sec square x dx is equal to dt. So after this substitution, question is reduced to t dt divided by 1 plus t cube. Now this is partial fraction of this type. Use a cube plus b cube. What is a cube plus b cube, Zaina? A cube plus b cube बताओ.
सर ए स्क्वायर प्लस बी, सर पता नहीं.
मम्मी से पूछो. जानवी तुम बताओ.
Sir, I'm too.
A plus a cube plus b cube is a plus b, a square plus b square minus ab.
Sir, मुझे a plus b whole cube आता है, ये नहीं आता.
A plus b whole cube is a plus b. A plus b whole cube, na? A cube plus b cube plus 3ab bracket a plus b.
Yes, sir.
So this question is now t dt divided by 1 plus t square minus t plus 1. So we have used a cube plus b cube is equal to a plus b into a square minus ab plus b square. So now this question is reduced to this type. One linear factor, another quadratic factor. One factor linear, another quadratic. So we'll use now partial fraction. One factor linear, another quadratic. T dt over 1 plus t square minus t plus 1. So t divided by 1 plus t square minus t plus 1. So a divided by linear factor plus b into differential of quadratic plus c whole divided by quadratic. Yeah. Take LCM. This would be b into 2t minus 1 plus. So you can substitute zeros. Zeros are only one zero is there. T is equal to minus 1. You can take t is equal to minus 1. You can take t is equal to half. And you can take t is equal to 0. T is equal to minus 1. T is equal to minus 1. Tell me ABC. Find A, B, and C. Hmm? T. When you substitute t is equal to minus 1, this term would be 0. No, minus 1 by 2. 2. So t square would be 1. This would be 1. This would be 1. A is minus 1 by 3. T is equal to half 1 by 2. A into 1 by 4 minus 1 by 2 plus 1. This is 1 plus half would be 3 by 2. This would be 0. So 1 by 2, what is A? A is minus 1 by 3. What is this? You take LCM 4. So what is C coming out to be? 4 by 3. What is C coming out to be? Half. No.
Sir, it's half only.
Half? Okay. So C is half. And when you substitute T is equal to 0, you get the value of B. B is 1 by 6.
Yes, sir.
Yes, sir.
We get all three values. So this, now over here you can replace ABC. So this is integral A is minus 1 by 3 divided by 1 plus T dt. Second part is B into differential. B is 1 by 6. Differential is 2t minus 1 by t square minus t plus 1 dt. Third part is C, which is 1 by 6, no, 1 by 2. 1 by 2 divided by t square minus t plus 1. It's a long question. So the first part is,
एक बार आप वो वाला पार्ट दोबारा बता सकते हो जिसके अंदर हमने टी को लेट किया? आई डोंट नो व्हाई उसमें मेरा कुछ गलती हो रही है। डिफरेंट वैल्यूज लेट किया जिसमें हमने
1 plus this tan x common, 1 plus tan square is sec square x. Sec square x dx is dt.
उसके बाद जब हमने डिफरेंट वैल्यूज लिए 1/2 एंड स्टफ,
T is minus 1. So minus 1 is equal to A, 1 plus 1 plus 1, and rest is 0. A is minus 1 by 3. And then T is equal to half. Why half? Because this will become 0. So 1 by 2. This is 1 by 4 minus 1 by 2 plus 1. This has become 0. This is 3 by 2 into C.
ओके सो
I've taken B into differential of quadratic. I'm not taking bx plus c because it's very long.
ओके
So this is minus 1 by 3 log of 1 plus t. Derivative of this is present in the numerator. I can directly write the answer. Log of denominator. It will be log of the denominator because its derivative is present in the numerator. And the second part we have to use perfect square, converting to perfect square. Coefficient t is 1 by 2, square it, add and subtract. So this third part is 1 by 2 dt divided by t minus 1 by 2 whole square plus 3 by 4, which is root 3 by 2 whole square. So the third part would be tan inverse, 1 by a tan inverse. So this was a pretty long question. All right. So one linear, one quadratic. This is the method. But what if both are quadratic? Then it becomes easier for us. If both are quadratic, it won't be that long. Then we do pseudo substitution for both, but entrance we can directly answer those questions. If both the factors are quadratic. And these are not factorizable. Both, hmm? Both the factors are quadratic, which are not factorizable. So you make pseudo substitution for boards, but in entrance we'll do directly. Don't differentiate. And a divided by y plus 1, b divided by y plus 4. Same method. LCM will get cancelled out. We can use zero method also, but now let's use equating the coefficients. So this is 4a plus b plus y into a plus b. This is called pseudo substitution. That is, let x square equal to y, but you don't differentiate. I have opened the brackets. Terms of y, take y common. Constant term like this. On the left side, there's no term of y. That means coefficient of y has to be 0. Constant term is 1 on left, right is 4a plus b. So a equal to minus b. Substitute here and get a and b. There's no term of y on the left, y into 0. So a is minus b. So b is minus 1 by 3. A would be 1 by 3. So this question is now a by y plus 1, which is x square plus 1. And b divided by y plus 4, which is x square plus 4. Tan inverse is 1 by a. So that is the answer. So partial fraction is question number 1515. Just 38 questions. Before the next class, you can finish them off. Abhi, you answer question. Which question? Question number 36. Answer this. Question number 15 ka 36th. First you multiply because numerator has the same index as the denominator, then long division, and then factorize the denominator, and then pseudo substitution solve. आपस में open the brackets. Since index of numerator is the same as denominator, we have to use long division.
तो सूडो सब्स्टिट्यूशन पहले स्टेप में नहीं कर सकते?
नहीं, वो pseudo substitution you'll do only for boards. Entrance हम directly करेंगे. So when you multiply the numerator, it's x4 plus 3x square plus 2. Denominator is x4 plus 7x square plus 12. See, if you want to divide, you can divide it long division, or else you can add and subtract the numerator so that it becomes the same as denominator. I can also add 4x square, so it becomes 7x square. I can add 10, so it will become 12. And subtract the same. So you can do this also. I have not used long division. I have simply added and subtracted terms so that this becomes same as denominator. Manipulate numerator so that it is the same as denominator. Even by long division, you get the same answer. क्या हुआ मेरा? कुछ गड़बड़ है?
Sir, I just like long division more.
ठीक है, आंसर वही आ रहा होगा. आ रहा है सेम?
सर अभी करूंगी.
करो फिर, बताओ मेरा गलत है क्या? Then divide individually this by this will be 1 minus common. So even the long division will give you the same only. So integration of 1 is this. And second part, you know how to answer. Factorize this again. X square plus 3, x square plus 4. For the second part, you have to use partial fraction. Now pseudo substitution. For I1, you can make pseudo substitution. Tell me A and B. To save time, you can take y is equal to minus 4. In the board, you basically open the bracket and equate just like we did in the previous question. But entrance, you can make substitution like this. So B is 6. Y is equal to minus 3. A is minus 2. So this part of the integral would be x minus a, which is minus 2 by x square plus 3, and 6 divided by x square plus 4, which is tan inverse. One by a This is your final answer. Hmm. Tired? So now for the homework, you have question number 15, entire, question 16, question 8, and I'm sure you have already done the previous ones, 9, 10, and all that. कर लिए थे ना जानवी?
Yes.
Done? Good. By God की कसम देख लेना, मेरा ने तो कर लिए सारे. कोई बर्थडे बर्थडे तो नहीं आ रहा अभी?
No, sir.
चलो फिर तो कर लोगे तुम. Now let's start with integration by parts. Last. Break. Integration by parts. Just like differentiation and integration also, if two functions are multiplied, we have a formula for integration. There are two functions, u and v, which are multiplied and we want to integrate it. There are two different functions. They can be inverse, logarithmic, algebraic, trigonometric, and exponential. I stands for inverse, L for log, A for algebraic, T for trigonometric, and E for exponential. It's always easy to integrate into exponential. So degree of difficulty goes up to integrate this way. So if the function is exponential, normally you integrate it. You take it as V. And this way, you basically differentiate it. So this you differentiate, this you integrate. And the formula for the same is u into integral of V minus integration of differentiation of du by dx into integral of v dx, the whole integration. I से था inverse, logarithmic, algebraic, trigonometric, exponential. So whenever you come across a question involving two different functions, we use this method of integration by parts. Like integration of x log x. X is algebraic, log x is logarithmic. So which one will differentiate? Log x. So this will treat as this would be as u, and this would be v. So let's apply the formula. U is log x, integration of x dx. Then derivative of log x and integration of x dx. The whole integration. So integration of x would be x square by 2 into log x. Derivative of log x is 1 by x. Integration of x is x square by 2. So now it is x square by 2 log x 1 by 2 out, integration of x dx. X square by 2 log x minus x square by 4 plus c. So this is the integration of x log x. Sometimes the second function is hidden, you don't know what is the second function. So we'll take it as 1. For example, you want to integrate log x. So the question is log x. Only integration of log x. So that hidden function is 1. So that you take as v. And then you integrate it. You should know what is integration of log x. Remember the formula. So if it's 1 dx, so it will be so integration of log x would be x log x. It is 1 by x, integration log x. So remember this formula. X log x minus x. Integration of log x is always x log x minus x. Integration of log x is x minus x. So that is it. Finish all these questions. Next class, more questions plus entrance level questions. Ending the class.
Thank you, sir.
Thank you so
Thank you,
much.
sir.
Bye.